This is a lesson for Tuesday, 126. This is live in person, but in case there's any issues, this video for you to watch to supplement what we did, or if you weren't able to make it in because of some issue, you weren't able to be in school. So, expression with the radical that we've been dealing with. First, we're going to talk about what it means to be in simplest form. Simplest form means that the radicands have perfect nth powers. It's kind of what we've been working with. The no radicands contain fractions, and no radicals appear in the denominator. And this is the key for today, that no radicals appear in the denominator. So what we come up with then is the fifth root of 7 over the fifth root of 8. And I cannot have this radical in the denominator. It does not work. You cannot do it. Okay? So what I'm going to do is I'm going to do what's called rationalize it. To rationalize a denominator, you need to multiply it by something so that it comes out perfect. We know everything when it comes to radicals is all about coming out perfect. So I need to make this denominator come out perfect. So I'm looking at my list of fifth roots. And the first fifth root I see is 32. So if I could make this become 32, then it's perfect. And I no longer would have a fifth root in the denominator, because then the fifth root of 32 becomes 2, and there's no longer a radical in the denominator. So what would I have? So first of all, we identified what we need to get to. What would I have to multiply by to get to 32? And clearly that's the fifth root of 4. So I'm going to multiply top and bottom. You know, with equivalent fractions, you have to multiply top and bottom to keep them equivalent. I'm going to multiply top and bottom by the fifth root of 4. 8 times 4 is 32. Fifth root of 32 is 2. Now in the numerator, I have 7 times 4, or 28, which is not a perfect fifth root. It doesn't simplify, but that's okay. But the big key is that I no longer have a radical in the denominator. So it simplifies into the fifth root of 28 over 2. That's exactly what's being laid out here as well. Okay, so the key is, what do you multiply the denominator by to make it perfect? It's all about making it perfect. So here on this one, I have the fourth root of 2/3. No fractions. We're going to use the property to break it up so that both the 2 and the 3 have the fourth root. So what do I need to multiply by? When I'm looking at the fourth roots, the number that jumps out to me is 81, because 81 is closely connected with 3. So I'm going to multiply by 27 on top and bottom. So now on top, I have the fourth root of 54, and in the denominator, I have the fourth root of 3 times 27, or 81. The fourth root of 81 is perfect. That's our goal, to make this perfect. That becomes 3, and the numerator just stays the fourth root of 54. I can do the same thing with variables. What I have here is x over the cubed root of y to the 8th. I need to make this perfect. And I'm not going to break it up. We're doing the opposite of breaking it up. We're multiplying by something to make it perfect. So I'm going to make this perfect. So what would make it perfect? If I have 8 right now, all I need to do is put in one more y, and it becomes 9. And now it's perfect. So I'm going to multiply by another y, or y to the first. In the numerator, that gives me x times the cubed root of y. Okay, whatever. In the denominator, I get cubed root of y to the 9th, which is perfect. It comes out as y to the 3rd. It's all about multiplying by something to make it perfect. That's the end of the lesson. Now, we're also doing in-class practice in class today. So I'm going to go through these. So if you want to stay on this video and go through these problems, you can. My suggestion is to pause, do the problem, and then unpause and see how I do it. Okay, so 23. I need a third root. Cubed root of 8 is perfect. So if I multiply top and bottom by the cubed root of 2, I get the cubed root of 10 over the cubed root of 8, which gives me the cubed root of 10 over the cubed root of 8 becomes 2, and I've rationalized it. The fourth root, this is actually very similar to the one we just did. Fourth root of 27, I'm going to make 81 out of it. So I'm going to do top and bottom by 3. So I have the fourth root of 12 over the fourth root of 81, which the fourth root of 81 is just 3. do some more review and practice in the last several days. So we're talking about the square root of 36 and 6. Break x to the third up into x squared and 1x. So 36. So the square root of 36 is 6. The square root of x squared is x, with an x left over inside. 20 is the same way. This is already perfect. 125 is perfect. Y squared can't become perfect, but z can be broken up. 3 z's and 1 z. So what I end up with is 5. Y squared is not perfect, so it stays inside. Z to the third, 3 divided by 3 is 1. And z to the first is trapped inside. And that's the final answer. We do 21 out here. I'm going to break 18 up into 9 times 2. K to the 6th is already perfect. Square root of 9 is 3. 6 divided by 2 is 3. And there's a 2 left over. It's the only imperfect one there. We have some rules of exponents to do. When we divide, we subtract. 4 sevenths minus 2 thirds. Common denominator is 21, so it's 12 21st minus 14 21st makes negative 2. And we know negative exponent means reciprocal, so it's going to be, I didn't leave myself enough room, 1 over x to the 2 21st. Here, power to a power, we multiply, so I'm raising. This is kind of just like a cumulative review. 2 to the third power is 8. 1/4 times 3, power to a power we multiply, is 3/4. Down here we're going to multiply. 2 times 6 is 12. When you multiply, you add exponents. Common denominator is 20, so it's going to become 8 20ths, equivalent fraction, plus 5 20ths, the equivalent fraction for 1/4, makes x to the 13 20ths. 12 times x to the 13 20ths. Here I'm raising 9 to the 1/2 power. Power to a power you multiply. 4 times 1/2 is 2. Power to a power you multiply makes negative 1. Now 9 to the 1/2, let's write that as a radical. The denominator is the index, so that means square root of 9. In fact, anytime you see 1/2, that means the same thing as a square root. So that becomes 3. X squared can't change. But y to the negative 1, that's a negative exponent. I got to put that in the denominator. Alright, last one, number 18 here. We're going to multiply these. I have the square root of 320, y to the 7th. That's going to be 64 times 5. 320 breaks up into 64 and 5. Y to the 7th is y to the 6th and y to the 1st. The square root of 64 is 8. The square root of y to the 6th is y to the 3rd. And then inside the square root is a 5y still left